I'm gonna share about postfix notation. The postfix notation is always move your operator to the back, but not all the way to the back. It's a back to the second operand. First of all, let's take a look of this expression. So right here, we have two brackets. So we're gonna solve the bracket first before we solve the rest. A is your operand and B is the second operand, and the multiply is your operator, so you will move the multiply behind B, so it will be AB multiply. And the right side, E is the first operand and the F is the second operand, and the right is the operator. So we are gonna do the same thing, just shift the right to the back of the F. So it will eventually be like this. So the AB multiply and the EF divided will be a postfix notation. The left side we have left with divided C, and divided is our operator and C is our operand. So we can eventually move the divided behind C, so it will become like this. So right now the left side is completely postfix notation. So we're gonna solve the rest first. So the right side, we have to solve the first bracket with content D and plus if F divided. This bracket has content D plus. So we will move the plus to behind the divided. So it will eventually be like this. So our first two brackets have solved. Like I said, if we have solved a bracket, we can eventually remove the bracket. And the next step is solve multiply G. Why multiply G? Because we always do multiply and divide first, and then eventually do plus and subtract. So we will move the multiply behind G will be like this. So that we will have left with plus and subtract as our operator. Like I said, when it left with the equal priority of an operator, we will do the left side first. So we will do the plus first. So we will move the plus sign behind multiply, so you will eventually be like this. So the last step is to move the shift, and the last step is to shift negative behind hash, so we can get our answer, which is AB multiply C divided DEF divided plus G multiply plus hash subtract. That is our answer for the postfix notation. And that's all for my presentation.
Good morning, my name is Dong Razor. Today I would like to take a moment to explain the incompleteness of a stack diagram, particularly in the context of editing a mathematical expression. We often encounter complex of expression in programming or mathematical computation, and understand how these are processed step by step can be facilitated through a stack diagram. Let's consider the expression. This mathematical expression involves additions, subtraction, multiplication, and also division. A stack diagram is a visual representation that helps us understand the sequence of operations required to evaluate such expression. Firstly, we identify the variable and constants in our expression, A, B, C, D, and E, F. Next, we recognize the operator, additions, division, subtraction, and also multiplication. Now we visualize the stack diagram step by step. Firstly, we need to process the bracket first, and then we need to put the multiplication inside. I would like to process from left to right, so I stack the letter. Then we combine it together. After that, we put the letter CD inside. Then we combine CD by divisions. Then we combine these two together by divisions. After that, we put the letter EF inside. Then we combine E and F with additions. And the last, we combine these two together. Additions. And this need to put a blanket. This is the part of stack diagram. And after that, we need to use this zero express way to consider the expression. Firstly, we push A inside and push B inside because this got a blanket, so we need to process this first. So push A, push B, and after that multiplication. After that, we need to push C and push D. After that, we need to divide because this got a blanket, so we need to divide first. After that, we subtraction these two together because this got a blanket. After that, we need to push E and push F. After that, we need to add additions and add these two together as pop Y. That's all for my presentation. Thank you.